Hello everybody. Hope you all are doing fine. This is your professor, Anindya Paul. Let's go over some of the basic control statements that we will use for Java. The control statement as a whole is pretty much similar. The concept is very similar in all the languages. However, the way or the syntax would change slightly from one language to the other. So some of the control structures that we will talk about here today, you probably have seen or experienced in other languages or in other classes. So we'll start off with things like the repetition statements like for, do, while. And we'll also look into some switch selection statements. And within the switch selection statement, we'll point out the use of the break and the continue. However, I must say that a lot of times programmers try not to use the break and continue. And then we'll finish out with looking at the structured program summary, and then also look into some of the GUI aspects with Java FX. So let's go ahead and get started. These are some of the repetition statements that we will be using, and these are pretty similar in all the languages. You have your for statements, you have your do while, we have your switch, and then we have our break and continue statements, and then we have the logical operators that we would use to write the condition, and then our control statements within. So we'll talk about some of the initial values, some control variables, incrementing and decrementing, which is central to the continuation of the loop. If we do not write them correctly, then we will end up in getting infinite loops. So let's take a look at some simple program examples. So here is a program example where we are using the while statement. The first two lines, 4 and 5, are pretty simple. This is something that we have already seen before. And then we start off with a counter. This is where you would initialize the control variable. And then in line number 8, we are writing a while statement, which is basically the repeating statement. And the condition that we write within the while statement is as long as the counter, which is initialized at 1, is less than or equal to 10. Remember, it is less than or equal. So when it turns 10, it will still continue. Only when it becomes anything other than 10 or more than 10, not other than 10, but more than 10, that's when it's going to close. So here is my start of my counter less than equals 10. Of course, my value at this point is 1. I go inside the method, repetition structure, and have system out print f. So it just basically prints out my counter, and then it increments my counter. Look at the spaces that you have over here, and the spaces are actually coming from the space that you see right over here. So again, we will start off with 1, go all the way up to 10. So the first time I would go 1, and then I would increment my counter. It becomes 2. Come in, print this, increment my counter. 3. Again, print it, increment my counter. So as long as the condition is less than or equal to 10, I cannot come out of this loop body that I had set up. Only when my counter becomes 11, I would not go into the while loop anymore. I would come in and say system out print line. So that would give me a space, and then that would end my program. So it's a pretty simple program, and this is the first way you can write a repetitive loop with the condition present right after the while statement, and then the counter has to be initialized at some point. Talks about why you would always use an integer value Why is it over here you would not use a double value? Because if you use a double value with the decimal points, you can actually get some approximation, which makes it difficult to control the loops. So we always use integer values to control the loops. Here is my other way of writing the same program, but in this case I'm using a for statement, and the parenthesis right after for statement actually includes all the three conditions that I would need. So I would initially define my counter as 1, then put a semicolon, and then my next statement is the control. So as long as this value holds or evaluates to be true, I would come in and do what I have said that I will do in line number 9, and then I will go increment my counter, and then I would again check my condition for my counter. If it holds true, I would go ahead and use the system out print line in line number 9, print it, and then go back and increment my counter again check my valuation of my counter. If it is evaluates to be true, do line number 9 again and go increment my counter. So this is going to continue until I come out of this less than equals 10, and at that point I'm going to come out of the for loop, which starts from here, ends over here, and then come to system out print line. So simple program. This is how we are going to be writing my for statement. Now what it's telling you over here is be careful about this statement right here, less than or equal to 10. If you make it only less than, then it would never reach 10. If you make it less than equal, then it will actually reach 10. So it depends upon what is it that you want to control. So be careful about the control statement. I already explained this thing to you earlier. So let's go in and look at what I had described earlier. My control variable, my condition, and then my counter, all of them needs to be separated with a semicolon in between. Now one thing I've seen in most of the initial programmers is that they have a tendency to put a semicolon at the end. As soon as you put a semicolon at the end, it would not reach the condition that you're trying to set up for the for or the repetition loop structure. So make sure that you do not put a semicolon here. Okay, so this is your for statement, immediately followed with a opening parenthesis and closing parenthesis, and the body is what is where you would write what is it that you want to be done inside the loop. So this is exactly what we just talked about. The same statement that we have written with while can be written with a for. So initially we had started with a for statement. Now we are looking at a while statement, and again everything that we can do with a while can also be done with a for statement. Talking about variables scope, this is something that you have already seen. A local variable can only be used in the method that declares it, only from the point of the declaration to the end of the method. So if you write a local variable within a method, then that's where it can only be seen. It is not seen on outside. About the incrementing, we can use counter plus 1, counter plus equals 1, or plus plus counter, or counter plus plus. This is again something that I'm sure you must have seen or experienced in some of the other languages. Already spoke about the semicolon. Be careful about not putting a semicolon at the end of the while or the for structure. Here is another for statement. In here it's trying to show you that you can initialize your values as j equals x, but then you have this condition j less than equals 4 times x times y. So this is where they're doing a condition, but they also have a little bit of math built into this, and that is also going to be acceptable for Java. And then for my repetition or my loop count, the increment of my loop, I can also use j plus equals y divided by x. Okay, so basically trying to find out how to write different ways of including things in the for statement. So this is the equivalency of that, and this is your UML activity. This is something that you would be seeing more and more when you get into the system design classes, where instead of writing the code, you would create UML diagrams so that the programmers now can understand what is it that we are trying to do. So this is our starting point, which is depicted by a closed circle filled in, and then your ending point, or this is the end process. So this is the start, this is the end, which is a concentric circle with one being filled and the outside being empty. And then I would start off with a control variable. This is where I would initialize my counter, and then I would go in and create my method, and then I would actually do a decision. So, or this is my condition that I'm trying to meet. As long as the condition holds true, I'm going to continue doing everything that I have written within my curly brackets for the repetition structure, but only if it comes out, I would go to this direction, so counter greater than 0, and then I would end my loop. So everything that you see over here is actually inside the loop. So it goes from here, comes over to the decision, and then this is where you have the counter. So this is where you have the decision, and then it just rotates between this. So counter, this is my decision, display counter, increment my variable, again go back, evaluate my condition, come back and look to see where my counter is, if the evaluate should be true, and then continue the process. Continuing on, these are some of the different ways you can write your for statement. So as you can see here, you have your plus plus, minus minus. Now it is not necessary that you only have to go up by 1 or less by 1. You can also go up by any number of values. So in this case, you're going up by 7 values. So more of what you can be used. So you have minus equals 2. So you're actually reducing 2 at a time. This is I plus equals 3, adding 3 at a time, and then you have minus less than equals 11. So you're deducting 11 at a time. Okay. All right, so let's take a look at another program over here. This is my program. This is my class called sum. I have my main method, and then I have a for statement in here where I'm actually trying to start the counter, or I've defined my counter as number and assigned a value 2, and then I'm saying as long as the number is less than equals 20. So of course at this point it is at 2 is definitely less than equals 20, and then I'm going to add it to the total number. So remember, my total is a variable that is holding 0 at this point. So at this point I'm going to add 2, but then I have to go and increment my counter. It's incrementing 2 at a time. So now this is going to be 4. Is 4 less than 20? The answer is true. And then I'm going to add 4 to this number. So as long as I keep on going this and then keep on going through my loop, if this condition is not satisfied or it's not met, I continue with the loop, and I kept on adding the value to my total number, and then I would then come outside the loop of the for statement and then print my total, and in this case your sum is 110. Anytime you have programs like this, I always encourage you to type the program and see how it is working. Okay. Here is another program that we have. So this is where you have defined your principal and your rate. As you can see, these are double values, decimal points, double rate, 5%. And then you have a system out printf. So you are actually spacing your output. So it's a string, and it is saying it's 20s, so the string is about 20s, and then you have a /n, and then you have a year, and then amount of deposit. Okay, what you're doing inside is writing a for statement. This is where you're using a counter at 1. As long as the year is less than equals 10, I would come in and do a calculation of my principal times math power 1.0 plus rate, comma, year. So basically this is a formula that I'm using. It's a math formula of power where I'm trying to add to the interest. And then I come in and then do a printout of the year and the amount. Okay, so this is what I'm going to see. So it's my year, amount of deposit, and then in year 1, if I start with $1,000 value, then I'm up to this number, and then year 2, I'm going to take the 1050 and add another interest percentage on this. Then it's going to be 1102. So this is basically a compound interest. So every time you're going from 1 through 10, it's adding the interest to the principal and added interest that you have gathered the last time. So this is how I go from year 1 all the way up to year 10. So then I start off with $1,000. I'm up to about $628 on that $1,000. That's, you know, the power of compounding. This is the section it talks about the formatting of those characters. So when you say you have a right justified or left justified, this is how you would differentiate between the right justified and left justified. And again, purely formatting for your data. So this is the method that I was referring to earlier. Math power xy calculates a value raised to the yth power. So this is where I'm getting the formula. And this is again going to be a formatting section over here. So if I'm doing 20.2f, that means you have 2 decimal points up to 20 numbers. So this is how you would separate them. Continuing on, let's look into a do while statement. So we had seen a while statement to begin with. We had seen a for statement. Let's take a look at the do while statement. This is a problem or a program completed with a do while statement. Basically, the do while, you would start off with a do statement where you would start off with the body. Everything that you need to be doing inside or need to be repeating is kept within the do statement. And then you have a while statement that checks the condition if it is true or not. So you start off with an automatic do statement and then you check to see if the condition is correct. And if it is, then it will go back into the do system and continue doing what is included within the do body. Okay, and that's how I got my output right over here. So this is very simple. Instead of using the for, I'm using the do while statement. Here is a UML activity for this. So, you know, it's showing you pictorially how we can start off with the decision, display the counter value, increment it, and then check the condition again. As long as it is true, it is going to keep repeating. As long as it becomes false, it's going to come out of it. Here is another program example. As you can see over here, I've initialized a lot of the values as integer values, all by default 0. And then I would use the system out print line, you know, this entire statement where now I'm using a Control D to stop the value. So on Unix, Linux, or Mac, you would use the Control D and hit enter to stop the input of values. But if you're using the program in a Windows, you're going to use the Control Z. So now I start with a while statement. Inside that, I have an input.hasNext. Now this is a special method which gives you a Boolean value, or which returns a Boolean value, either true or false. So as long as you do not use one of these characters, Control D for Unix, Linux, and Mac, or Control Z for Windows, it will continue to take in values and keep on adding it to my total. Okay, so that's basically your program. what we're doing over here is, instead of writing the for or the while, I'm using a switch looping statement. So here is my keyword switch, and then this is the condition that I have while grade is divided by 10. So then you have cases. So anytime your value is at 9 or 10, then you're going to go ahead and take that value in, case 9 or case 10, and then you're going to increment your count, and then you would break. So basically, when you have a value which is 9 point something or above 9 or 10, you're going to increment your A count. So if you go back to your previous variable over here, so this is basically a way of keeping the grade count of A, B, C, D, and F count. So this is how I'm going to go ahead and do 8. So if I divide this by 8, and if I get anywhere between 8 to 80 to 89, I'm going to increment to the count, B count, and then anything between 70 to 79 would be C, and then you have your 60 to 69 as a D, and then by default it is a failing. But if it is not any of those things, it's a failing grade. So this is your switch statement that we are using, and I can do the same thing with an if statement just like this. It's just showing you how you can do this. So I kept on taking the values, so 99, 92, 45, and then I have Control Z, and that is where my program knows that it does not have any other values anymore.